Hello everyone. So when it comes to temperature, we are always given a specific number like 26 degrees Celsius or 27 degrees Celsius of being the accurate measurement at that particular time. But do you know that when a weather forecast system is given, they give you actually two numbers, which is one is the maximum temperature and another one is the minimum temperature for that specific day. Similarly, when you go to a stock market, you will always see numbers fluctuating in red or green colors, and sometimes they are also in white. Do you know what are these numbers? They are exactly the prices of a stock or the percentage change, where red number depicts that the stock is going downwards, or rather the price of the stock is going towards lesser amount, and with the green it shows the opposite way, which is in the increasing manner. So if we take the highest stock price, which is given in green, and if we call it as a maxima, or rather a maximum value of that particular day, and if we call the lowest stock price as the minima, it will actually show us a graph where we actually get 2 points in a day, where it starts to fluctuate the share price in between. So why am I telling you this when I am trying to tell you what is the topic of maxima and minima? Well, we are going to see in our work tool how can we actually take out the maximum and minimum value of functions. So now we are inside a work tool where we are going to see what is maxima and minima in much deeper details, right? So before we start on to finding what are local minimas, what are local maximas, before we start to find out what is the inflection point, what is the derivative, what and how the tangents affect the points, let us take an easiest example and try to learn from an example how to solve the problems. So this function is y equals to x square. So this is an easiest graph you can find and try to solve it for the purpose of maximas and minimas. So what is the minimum value of this function? So it is clearly given over here, which is 0. So when you put x equals to 0, your y is going to be 0, right? So this is your minima, which is nothing but the minimum value of a function, right? So in the previous video we have seen that to the right from 0, this function is increasing function, and towards from left to 0 it is an decreasing function. But we don't have an exact upper value or the highest value for this function, which is y equals to x square. So in this case we don't actually have a higher number or the maximum point of this particular graph. So what does this tell us? It tells us one thing, that we need to have an interval or a domain in which we are going to find out the whole purpose of the maximum and minimum values of that particular functions. So why do we have this? Just like the examples of having the temperatures of a day or the stock market prices of a particular stock, we need to have a set time frame in which we can compare the values. So in the next part we'll see how are these. So if we come to the nature of functions geometrically, in the previous video we have seen how the points are inflecting and how the nature of the graph is changing. So we'll take 4 points, which are basically A, B and C, A, B, C and D. So from these 4 points we can say two things. There are two upper points which are B and D, and there are two lower points which are A and C. And these points can tell us a lot about how to find the minimum and the maximum value of a function. Well, how? If you see to the left of A point over on this side, the function is a decreasing function, and towards the right it is an increasing function. And by this we can pictorially see that the A point is at the minimum possible value of that function, right? So but at the same time, even at point C it is having the same condition, but for the purpose of point B and D it is exactly opposite. So in case of a, towards left it had decreasing function, right? So if there is a point a, so towards left it was decreasing and towards right it was increasing. But in case of b and d, towards left it is an increasing function and towards right it is a decreasing function. So what is increasing and decreasing function? We have already seen it in the previous video. So the I button will be over here, or you can check it on my channel. But since we know this nature, we can directly come to the next part, which is understanding what are tangents. So we know that derivatives are used for finding the slope or the tangent of any function. So if you look in these functions, what is tangent? Tangent is nothing but opposite upon base, which is nothing but tangent. So if a theta is given, so it is necessarily the height upon the base. But if you go on to point over here, so let's just say that the point C is over here. Can we say that there is no going to be change in height since the point it is at the peak? So if the point C is at the peak, it is going to have f dash of C as 0, isn't it? So this is why finding tangents or finding slope is very important, and we have combined the knowledge of two functions or the nature of functions and tangent properties into one, and we can understand that this function, or rather this point, which is f of c, is at the max point of this particular functions. So in short, I'll simplify it and try to tell you that when there is a point, let's say that point is C. So when there's a point, if towards left of it you have an increasing function and to right of it if you have decreasing function, then that point is at maximum. And opposite, if the point C towards left it has a decreasing function and towards right if it is an increasing function, it is a minimum point. But what if we don't find all these types of natures of graphs towards left and right? Then we have a point of inflection. So what is point of inflection? So if you properly see, well, in this case towards right the function is increasing, isn't it? But towards left also this function is actually increasing, isn't it? So if you see the height, it is directly increasing. So when you have a point C, on the left side also you have increasing, left side also, right side also you have increasing, then the nature of the graph is we cannot tell it. So at point O or point C, we have an exact point of inflection. So in the next part, we are going to see what is first derivative test. So now we had knowledge that we need to define the domain. So we now have domain with us. We also know what is the nature of graphs. Yes, but we also have the knowledge where if the function is decreasing or increasing on either right or left, or increasing or decreasing from left to right, we can tell what is the maximum and minimum. So what is first derivative test? First derivative test particularly says that if there is a point C1, in this case we'll take it as C1, if it has derivative f dash of x greater than 0 towards its left side and f dash of x less than 0 towards its right side, then that particular point C1 is the maxima or local maxima of that point, of that graph over the given domain. So you need to have a given domain and you can directly say that that particular point is the local maxima. Okay, so we'll take C2 now, and in case of C2 it says that if f dash of x towards left, if the function towards left, so it should be less than 0 towards left, and if f dash of x towards its right side is greater than 0, then this function is going to be your local minima. And these particular points are just giving you the exact information where the function's value is going to be maximum or minimum. These are not the values, exact values of that particular functions. So we'll try to take an example and then we'll try to understand how this works. Okay, so we have an example based on first derivative test. So the question is, f of x is x cube minus 3x plus 3. So if you see in this case, the function is directly given and we need to check what are the local maxima and minima points, and then we have to find out the values of that points when you insert into the function. So the first step will always be f dash of x, which is going to be 3x square minus 3. So can you simplify it further? Yes, if we take 3 common, you have x square minus 1, which can be also written as x minus 1, x plus 1, right? And here we need to check if the function f dash of x is going to be 0 at what values. So they are going to be 0 at what values? They are going to be at x equals to 1 and x equals to minus 1. So if you put x equals to 1 in these terms, the whole function value is going to be 0, and if you put x equals to minus 1 in this term, the whole term is going to be 0. So you have two zeros, which is 1 and minus 1 for this particular function. Now we'll see by putting in the values with respect to f dash of x, what do we get, right? So we'll take first x equals to 1. This is the first case, and let us take two values. So if you have 1, they are going to be two nearest values, right? So which are going to be 0.99 and let us take 1.01, right? And let's try to solve this. So what is f dash of x? We had 3x square minus 3, right? Now if you put 0.99, is this term going to be positive or negative? So it is clearly, this term is going to be less than 0, so this is going to be less than 0. And in terms of 1.01 squared minus 3, this is going to be greater than 0. So if a point in this case is over here, and towards the left the function is decreasing and towards the right the function is increasing, so can you say that this point, particular point 1, is the minima, isn't it? As we have previously stated. But in case of minus 1, so if we take x equals to minus 1, so it is going to be 3 times minus 0.01 squared minus 3, and this is going to be greater than 0 since this is going to be greater than 1, and 3 times minus of 0.99 squared minus 3, this is going to be less than 0. So if you take it on a graph, and if this point is minus 1, so on left side the graph is increasing, on the right side it is decreasing. So you can say that x of minus 1 is the maxima of that particular function. Now we have found out the only 2 points which are going to give us. So x equals to 1 is going to be the minima or the local minima, and x equals to minus 1 is going to be maxima, as we have stated. But what are the actual function values? We are going to directly put it and we are going to find out. So f of x is going to be 3x squared so f of x is nothing but x cube minus 3x plus 3, isn't it? F of x is going to be x cube minus 3x plus 3, and hence at x equals to 1, we are going to have f of 1 as 1 minus 3 plus 3, which is going to be 1. So f of 1 is going to be 1. And in case of at x equals to minus 1, f of minus 1 is going to be minus 1 times whole cube minus 3 times minus 1 plus 3. So here you have minus 1 plus 4 plus 3, which is going to give you plus 6. So your maximum value or local maxima for this function is going to be 6 and the minima is going to be 1. So this is how you're going to find out what is the local maxima and minima. So there are 4 steps. I'll once again repeat. First, you need to differentiate. So you need to find out f dash of x. Then you need to find out the points. Then you need to check the points with f dash of x being greater than 0 or less than 0. And then you need to plug in the values for finding maxima and